So here's an example of a sequence. What's the next term? 31, 37, 43. And can you write an expression for the a sub n term? Let's see, a sub n, I'm adding 6 each time. And if you do the little trick I showed you before, if I count this as term number 1, let's do this term 1, 2, 3, 4, 5. If you back it up to the 0th term, what would the 0th term be? 1. So it's really just mx plus b. 6 or rather, I'll use an n instead of an x. 6n plus 1. That should work. There are other ways you could get it. This type of problem where you're adding the same number each time, this is an arithmetic sequence. This is an arithmetic sequence because we're adding the same thing each time. And in fact, the number I'm adding is called the common difference. The number we are adding is called the common difference. If you are multiplying, here's an example where I'm multiplying. It's called the geometric sequence. So I have 1, 2, 4, 8. What am I multiplying by? 2. Oh, I wrote 2 commas. 16. How about blank, blank, blank? So what goes in the next blank? 32, 64, 128. It goes forever. And if I'm multiplying, this is a geometric sequence. So when we multiply to get the next term, it is a geometric sequence. This is also called an exponential sequence or an exponential sequence. So here's the words, geometric. So when we say that, we mean we're multiplying to get the next term.
Is there a common difference?
There's actually a common ratio.
Okay.
So the number you're multiplying by is called the common ratio. The number you are multiplying by is called a common ratio. Can you write an expression for the a sub n term in this one?
2 to the n.
2 to the n, that's it. Well, if n starts with what?
If n starts with 0.
If n starts with 0.
Greater than or equal to 0.
A sub n is 2 to the n for this problem, and n is starting with 0, and we just assume there that n is an integer. Just when you see n, we would assume that it's an integer.